Hello friend, how are you? I hope you all will be fine. I am fine, thank you. So let's start lecture number 2 of crystal field theory CFT. Crystal field theory, and this topic and today topic we will be discussing grouping of d orbital. D orbital I already explained in previous videos. You may can search in YouTube that how orbitals are oriented in space, or you can also or you can also you can also search shape of orbital in YouTube. Search You can also search shape of orbital by chemistry technique. I explained the shapes of different orbital with very detail, and this video had almost 22 minutes. I explained with very detail. So here in crystal field theory, the d orbital, you know that the d orbital, why only d orbital, why we cannot interact s orbital or f orbital here? Because s orbital or p orbital here, because s orbital is inner orbital. It is inner side, it is inner orbital, while d orbital is outermost. D orbital are interact with d orbital have interaction with the ligands in a ligand field theory and crystal field theory. So this crystal field theory, sorry, here in this grouping of d orbital, what is meant by grouping of d orbital in crystal field theory? When we discuss the different compound like octahedral complexes, we will be discuss this in next video. Octahedral complexes are tetrahedral complexes are tetragonal complexes are square planar complexes. We will discuss these all with very detailed, that how crystal field theory involved in the octahedral complexes, tetrahedral complexes, tetragonal complexes, as well as in square planar complexes. These complexes will occur, these different geometry will form in crystal field theory due to the splitting of d orbital, due to the grouping of d orbital. How the grouping of d orbital will occur? So in today's topic, in today's lecture, I will explain you what is meant by grouping of d orbital. I already told you in previous lectures that d orbitals have d orbitals have 5 degenerate orbital, 5 degenerate suborbital. D orbital have 5 degenerate subshell suborbital. What is that? These are dxy, dxz, dyz, dx square minus y square, and dz square. These all are degenerate orbital of the central metal atom. These orbital contained by central metal atom. These orbital are these all orbital have same energy and same symmetry, because these are degenerate orbital. So in crystal field theory, these degenerate orbitals have same energy and same security. When the central metal atom, let's suppose that is central metal cation, M plus N, where N is the oxidation state of the central metal atom. So when ligand approaches the outermost electron, the outermost shell, and outermost there is a d subshell, d shell, and d shell there has 5 degenerate orbitals. These 5 degenerate orbitals all have same energy and same symmetry. when ligand, according to crystal field theory, when different ligand approaches in different direction toward the central metal cation, in this case, the d orbital, all the degenerate orbitals of like dxy, dxz, dyz, dx1 minus y square and dz square, these will be split into different sets, into different grouping. So now in this lecture we will focus on the grouping of d orbital. So what will be happen when the ligand at depend upon the ligand approaching toward the center meridian, that what will be the result of the shape of or the geometry of the complex. So the approaching of the ligand will discuss later, we will discuss it later. So and now I am telling you the grouping of d orbital. There are n d subshell, n d shell, and d orbit, and d orbit, and d orbit. There is 5 degenerate orbital like dxy, all have same energy. This is the energy graph, like this is the energy that increasing upper. So there, these 5 degenerate orbital, these orbitals of dxy, that is central metal atom that have 5 degenerate orbital, that are dxy, dxz, dyz, dx square minus y square and dz square. These 5 degenerate orbital of central metal atom, when ligand approaches to and different interaction, they will split into two different types. They will split into two different types. Either it will be split, it will only split into two sets. That will be, one will be eg sets, one will be eg set, and the another will call be t2g set, t2g set, that called t2g set, that is called eg set. Is that right? What is meant by eg sets? Why this splitting occur? Why this grouping occur? These grouping, these grouping depend upon the splitting, this splitting, this splitting depend upon, this splitting depend upon the approaching, the approach of, the approach of, the approach of ligands toward metal. The this splitting, the splitting depend upon the approach of ligand toward metal in and the on the pathway, in which pathway, in which pathway at approach. The splitting depend upon the approach of ligand toward metal and which pathway at approach. The splitting depend upon that the ligand approaching to the central metal cation according to column law. It will be make some interaction, it will be make attraction, because these both charges are different charges. One is positive, central metal atom has positive charge, while the ligand has negative charge. So there will be attraction occur. So how the ligand interact, how the ligand approaches to the central metal, these are either, these are approaches along x-axis or in between x-axis. These will depend upon these approaching. So these will after that it will occur when the ligand approaches to the central meridian. Then the energy of the d orbital, some of the degenerate orbital in d orbital will have energy decrease, and some will have energy increase, because it will depend upon the ligand approach towards central meridian. So we will discuss at that how, that why, and that which ligand have energy increase and which one have decreased. The d orbital will split into grouping. One will be eg set and the other will be called t2g set. What is eg set? Eg set is called, eg set, this set is called each set contain there are total 5 degenerate orbital in d orbit uh, that has a dxy dxz dy dx minus y square dz square, while the dx square minus y square and dz square, this will be categorized and eg set, while and t2g sets the dxy, the remaining dxy dxz dyz dyz, these will be categorized in t2g sets. The eg set is called that is also called doubly degenerate. Eg means doubly degenerate. It means it will be degenerate doubly, that is one time, that is two times, means two orbital will be generated here, but here three orbitals will be generated, so it is called t2g will called triply degenerate orbital, triply degenerate set, triply degenerate set. So is it clear? So why dx square minus y square and dz square are categorized in eg set, while dxy dxz dyz are in separate groups? It is because I already told you in the detail in previous video. I already told you now that hmm, that you can search my video how orbitals are oriented in space or shape of orbital by chemistry technique. So in my channel you can also in detail that how and that what is the shape of these orbital, how they are oriented in space. So I already told in that video before, I told you that the dx square minus y square approaching or lying on that is x-axis, that is y-axis, that is that is the one lobe and that is the another lobe. So that is on x-axis and this is on y-axis, and this is called dx square minus y square, this orbital called dx square minus y square, while d orbital have double dumbbell shape. So that is one dumbbell and this is another dumbbell, these dumbbell are lying on exactly x-axis, so that is called dx square minus y square, while if there is the z-axis, if this is z-axis and one dumbbell lie on z-axis and the other one across arrange a circular on this z-axis, so that will be one double and this is another number, so it will called dz square. So these orbitals are lying exactly on, these orbitals are lying exactly on x-axis. So why, that's why we categorize these two orbitals on separate sets, because these orbitals only lie on x-axis, while it mean that. So let's suppose that is the that is orbitals. So let's suppose that the green orbital is x-axis, while the white pin, the green pin is, the green marker is x-axis, while the white marker is y-axis, while the red marker is z-axis. So this is in space three-dimensional structure. So here if one orbital lying in this case like dz, one lobe, one dumbbell in on x-axis and one dumbbell on y-axis, this will orbital will called dx square minus y square. If the one orbital is lying in z square and the other will spherically around the z, so it will be called dz square. So these all orbital own exactly lying on axis, while the dxy minus dxz, how they arranged, that is x-axis, that is y-axis. So dxy orbital, it is in between xy, one lobe will be here, one dumbbell will be here, one dumbbell will be here. So this will be on x-axis, so in between axis, while and dxy dxz, that is that is let's suppose that is x, that is x, and that is z. So the lobe will be like that, mean that will in between x, these all lobe will be in between x z plane. If let's suppose yz, yz orbital will show like that, that is let's suppose y orbital and y axis, that is z axis. So in between these orbital, this number will be like so that orbital will be called dyz, and this orbital will be called dxz, and this orbital will be called dxy. Like I am showing that in here. Let's suppose I already told you that sorry to so I already told you that the blue marker is on x-axis and that is white marker is on y-axis, while red marker is on z-axis. So let's suppose that is x-axis, that is y-axis. If the orbital one lobe is here, one lobe is here, one lobe is here, one lobe is here, these all are in between axes. These all are in between xy plane, xy plane, xy plane, xy plane. So it will be called dxy. When orbital line on like that is z and that is y, like that one, so like that one, that one lobe will be like that, and one lobe will be like that, one lobe will that one dumbbell will be like that, one dumbbell will be like that. So that is that orbital will be called dyz, and this orbital will be called dxz. That is x plane, that is y plane, that is z plane. So one lobe will be here, one lobe will be here, one lobe will be here, one lobe will be here. So this will be called, one lobe will be here, this will be called dxz. So this will be so uh, when ligand so now the question is, so these are orbital are in between axis, that's why we categorize it into t2g sets. That's why we categorize the t2g set, eg set separately, and eg sets all orbital are lying on axis, while in t2g set all orbital are lying in between axis. It is a in between axis, while it is on the axis, it will be on the axis. So why the splitting occur, why the grouping occur? So let I'm showing that there is an when let when the sex coordinate complex, when there is sex ligand approaches to the central metal, let's suppose there is central metal atom. These are the five degenerate orbital are arranged or oriented in like this that I explained before. So when ligand approaches, when sex, there is sex ligand, when ligand approaches in this direction, one is from this direction, one ligand is from this, one is from this, one is from this is four ligand that is on xy plane, and one from this, one from this. So these all are interact directly interaction with the these all have directly interaction with these orbital. I mean that eg sets decline on these axes, these will directly interact the ligands. So this energy will have these orbital will have increase their energy, but the in the those orbital like t2g sets which are in between axes, they cannot completely face the ligands. So that's why their energy will be decreased and the eg set will be increased. So that's why the grouping will occur when if the ligand will like in tetrahedral structure, if the ligand will approaches in between x, if the ligand will approaches in between x's, like here from here in between x's, so the in between x's, the t2g set, that energy will be high, they will be increased, while the energy while the orbital that lying on axis that cannot completely face the orbital, the ligands, there, so that energy will be decreased. That has the grouping of the orbitals. I hope you will be completely understand. I hope you will be completely get my points. These all are grouping of orbitals, how orbital grouping will occur in the CFT, crystal field theory. And next topic we will discuss the crystal field splitting in a octahedral complex, how octahedral complexes will formed. So and next chapter we will discuss. So either you, this is our uh, lecture number 2 of CFT, grouping of d orbital. You can take also screenshot, or you can pause video, or you can rewind video, so that I hope you will be clear. Thank you very much. Please subscribe my channel, all support me. it make me feel happy. Thank you very much. Goodbye, best of luck.